Right now we are about to quickly review how to go about finding the number of an element on the periodic table, as well as how to draw an atom of each. So to start with, we're going to find these four elements on the periodic table so we know their elemental number and how many electrons and protons we need to add into our drawings. So let's start by finding phosphorus, which is the letter P. I can see the letter P right here. It is 15. So now I know that phosphorus is element number 15. And make note of that. Next, let's do carbon, which is C. C is number 6. Now we'll do iron. Iron is 26. And lastly, vanadium, which is element V, and it is number 23. So we're going to quickly place in the electrons for these four atoms, simply so we can recall how to do it. I've already put in the appropriate number of protons into each, just so that it goes a little bit quicker in the video here. Again, the first valence shell, it can hold 2 electrons. We need 6 in carbon, so we're going to do them side by side. So 1 and 2, and then all the rest of the valence shells that we're working with will hold 8. So we used 2 electrons. 6 minus 2 is 4. We need 4 more. This valence shell can hold 8. We only need 4. And again, when we go in to plug in these electrons, we're going to use the Konami code here: up, down, left, right. So up, down, left, right. This is the way that I would like you to place in your electrons. If you have your electrons in any other arrangement, that is not what I'm looking for. Let's move over to phosphorus, element number 15 here. Already got the electrons in, or protons in. Again, the first valence shell can hold 2. The second can hold 8. We need 15. 15 minus 2 is 13, so we need 13 more. 8 of those 13 will go in this valence shell. Again, Konami code it: up, down, left, right, up, down, left, right. So now I used 2 plus 8. I used 10 electrons. 15 minus the 10 I already used is 5. I need 5 more. The third valence shell can hold up to 8. I only need 5. So we're going to go Konami code it again: up, down, left, right is 4. I need 1 more. Back to the top, up. And there we got phosphorus. Again, you can see phosphorus, there are 2 paired electrons at the top, but single electrons on the sides, as well as the bottom in that outermost valence shell. Lastly, almost last, vanadium here, number 23. Again, first valence shell holds 2, 1, 2. The second one holds 8, up, down, left, right, up, down, left, right is a total of 10 electrons now. 2 plus 8. I need, looks like 13 more. 23 minus 10 is 13. I know my next one can hold up to 8. I need 13, so I need to fill it. Up, down, left, right, up, down, left, right. Now that valence shell is full. I used 3 valence shells. They are all full. Now I got to go out to my 4th valence shell. 2 plus 8 is 10, plus another 8 is 18. 23 minus 18 is 5. I need 5 more electrons in the next valence shell. So again, Konami code: up, down, left, right is 4. I need 1 more. There we go. I got my 23 electrons. Notice that there is a pair of electrons on top. There's 2 singles on the sides, 1 on the bottom. Lastly, number 26, which was iron, are 2 electrons in the first valence shell, are 8 electrons in the second valence shell. That's 10. I need 16 more. 8 more electrons can fit in the third valence shell. Up, down, left, right, up, down, left, right. And 2 plus 10 plus 8 is 18. 26 minus 18 is 8, and this next valence shell can hold up to 8, so it looks like we will fill up this valence shell, again using the Konami code, up, down, left, right, up, down, left, right, and as you can see, we kind of have a pattern going here, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. It's kind of flowing in that arrangement.